Okay, not sure what happened there, but we're still showing, so we know that this diverges. Basically, it doesn't matter if it converges or diverges. We just know that if we get a limit when we divide the two, then they both act in the same way. Okay, and so we've compared it with something up here, something that converged, here with something that diverged. So if we get a limit, when we compare the two, we're going to state then that this diverges as well. So we write the limit as n goes to infinity of a sub n over b sub n is equal to n squared over n cubed plus 1, and then I'm going to just go ahead and write that as divided by this is going to be times n over 1. Okay. Alright, so this is then the limit as n goes to infinity of n cubed over n cubed plus 1. So same power on top and bottom again. And we know that because these are both degree 3, leading coefficient over leading coefficient, we get a limit of 1. So since we got a limit when we divided the two series, both have to have the same behavior, so a sub n diverges. Okay, yikes, I'm not so sure about this one, but let's try it. So I'm going to take a look and I am going to compare it to something a little simpler. I'm just going to do n squared over 3n to the 4th plus 1, which is simpler, and which, again, if you're looking over this, we would know that this does converge. So I'm going to divide these two. They have a common factor of this, so we're looking at the limit as n goes to infinity of, once again, n squared minus 1 on top and n squared right here. So we can see, again, these are the same degree. This has a limit of 1. So since b sub n converges, a sub n also converges. Okay. So that is the direct comparison test and the limit comparison test.